Contemporary art is actively embracing algorithms, artificial intelligence, and computational processes. In this context, it becomes important to systematize different strands of synthetic media art, where technology and creativity merge into a single whole. By distinguishing types of art according to the principle of algorithmic complexity and methods of visual content generation, three major directions can be identified. Generative art is created through algorithms, rules, often incorporating elements of randomness, interactivity, and transformation without machine learning. Procedural art relies on pure mathematics without random input data. Procedural art is built on strict algorithms and precise formulas that generate forms and patterns according to predefined rules. Artificial intelligence art relies on machine learning methods and neural networks, allowing the computer to learn to generate visual content. Grid-based generative art. We can define some types of art by grid structure: simple square grids, regular grids similar to those in Excel, semi-regular grids, hexagonal grids, and Voronoi cells resembling cracks in ice. Polar grids, where instead of horizontal and vertical coordinates, each point is described by a radius and an angle relative to a reference direction. In generative art, polar grids are used for spiral ornaments, radial structures, and rhythmic circular compositions. Grid-based generative art can also be approached through the rules governing element placement. Trouché tiling. The main feature of a trouché tile is that any tile can be replaced by 4 tiles, inverted and scaled to 1/2 while remaining seamless. Another perspective focuses on the dynamic interaction, for example, of agents or particles with a grid, as in Langton's ant or sand pile models. Grids have been used for centuries, offering a simple yet effective structure for organizing space and breaking information into measurable units that are easier for us to process. Neural grids in the brain, the faceted eyes of insects. Since ancient times, urban planners have used grids to plan city territories. If we see a grid with a single direction of movement, it is most likely just mouse cursor coordinates, the mouse position. This can be replaced by code or a sensor, for example, Kinect. But the system can be made more complex. If we see many movements in different directions, we are dealing with agents. An agent's behavior is defined by an algorithm such as random motion, environmental response, or fractal logic. It can be made even more complex by assigning different reactions to different agents depending on axis or speed, and by incorporating memory of previous positions. Artists Agnes Martin and Sol LeWitt in the 1960s used the grid as a tool to convey inner harmony, a connection to nature, or to emphasize the impersonality of art. A series of static grid-based artworks by the Argentine artist Manola Gamboa Naon. Generative works often draw inspiration from phenomena at the intersection of culture and the exact sciences, as in work of Elias Steen. Gravity Grid is largely inspired by the algorithmic beauty of the board game Go, which is 2,500 years old. Go is based on placing stones on a 19 by 19 grid, where each move creates new patterns. The game has an immeasurable number of possible positions, converging toward an almost infinite diversity, similar to what is found in generative art. In Gravity Grid, the Go grid serves as a starting point, but is then transformed by gravitational distortions, producing psychedelic dynamic compositions. The Voronoi pattern. The Voronoi pattern is an algorithm for partitioning a plane into cells around a set of points. The main principle is to define the region around each point that is closer to it than to any other point. The unique Voronoi pattern has its roots in the beauty of nature. The seemingly random arrangement of geometric shapes governed by an algorithm can be found in giraffe spots, dried soil, the delicate veins of leaves, or the structural patterns in dragonfly wings. This is why it is so often used to create organic, natural, and grid-based generative textures that imitate water waves or stone formations. In 3D graphics, Blender includes a built-in Voronoi texture node that helps create textures with crack or mosaic effects. By animating individual cells, separating them, rotating them, or increasing their transparency, it is possible to simulate destruction or crystallization processes. Voronoi diagrams are also used in ambient graphics to create meditative backgrounds and animations, as well as abstract patterns. In Unity, developers can use Voronoi algorithms to generate landscapes, random maps, or biomes, ensuring a unique player experience each time the game is launched. Brand identity for Coher. Voronoi patterns in the brand book of the New Moscow project. An architectural center building in Riyadh. stylized Voronoi geometry in a music video.
Everywhere I go, I get a standing ovation.